Hi class, today we want to talk about subatomic particles. In the last class we spoke about the CERN supercollider and how we use the CERN supercollider to smash charged particles together and and look at what comes out. Um, Before we do that, I just want to review what we thought uh, everything was made up of. And we thought all the elements, here you have hydrogen and helium. And what you see here is a nucleus and a electron that's orbiting around the nucleus. And so we thought that all elements were made up of this nucleus with these charged particles and electrons orbiting around the nucleus. So all these different elements that you see here, basically everything that we know, everything that we can see, um, consisted of really three particles: electrons that orbit around the nucleus, and in the nucleus, protons and neutrons. So that really was our thinking of, uh, of of all matter. That all matter was really made up of these three particles: the proton, the neutron, and the electron. Um, but then we uh, we get our super collider and other means of investigating particles, and we smash things together and we see, gosh, it's other things come out. It's not just protons, neutrons, and electrons. And so here, for example, here's our super collider, and these are collisions, and lots of things fly out. And so here's a proton. The proton here is being represented by three particles inside of it, and they accelerate these protons in the super colliders, and they smash them into each other. Okay, and then we basically look at what comes out. So you have these charged particles that are getting accelerated down the super collider, and then they come into one of the detectors, like the Atlas detector, and they smash into each other, and we look at what kind of particles come out. And they can tell, um, based on how those particles move, if they are charged particles or uncharged particles. So you sort of get different things coming out when you smash these particles together. All right. And and let me look over here. Yeah. And so basically, this is just a simple picture here. You can see some particles, when they come out, they kind of take curved paths. Those are charged particles. Some particles, when they come out, go on straight lines. Those are uncharged particles. So they use this big, giant detectors after they smash the particles together, and they look at all the different particles that come out and what kind of paths do they take. All right. And when they did that, they found that they were discovering lots of things. So you can see all sorts of. All of a sudden, they're saying, "Hey, it's not just protons, neutrons, and electrons. It's all sorts of things." So there was a period of time that they referred to this as the particle zoo. They haven't really organized this, but they just said there's lots and lots and lots of particles out there, and so they needed to figure out how to organize all this stuff. And it turns out that a lot of these many particles that they discovered were really smaller particles just being combined. Okay, and they looked at all those particles, as I was just showing in that last image. And as I said, they for many years they sort of referred to it as a zoo of particles, because they said we discovered all these different things. We just don't know how they're organized, and they made big tables of all these different particles that they thought they had discovered. And it was only after a while that they figured out that many of these particles that they thought they had discovered were really just combinations of a smaller number of particles. And what I want to focus on today is just two items, protons and neutrons. And it turns out protons and neutrons are actually comprised of three things each, and they're called quarks. And protons are comprised of two up quarks and one down quark, and neutrons are comprised of two down quarks and one up quark. And so each of these things that we thought of as a single thing, we thought a proton was a proton and a neutron was a neutron, they're actually comprised of three things. Protons are comprised of two up quarks and one down quark, and neutrons are comprised of two down quarks and one up quark. Well, if you remember, protons have a charge of +1. Protons are positively charged, and neutrons don't have any charge. Neutrons are neutrally charged. So how do we get these two things that are kind of made up of the same thing? They're both made up of quarks, but how is this one positively charged and this one doesn't have any charge? Well, it turns out that these quarks have a portion of a charge, a fraction of a charge. And the up quarks have 2/3 of a charge, so you have +2/3, +2/3. And the down quark has a charge of -1/3, so +2/3, +2/3, -1/3. If you add all that up, that adds up to +1. So the charge on a proton is +1. A neutron, which is comprised of a down quark, and an up quark, that's -1/3, -1/3, and +2/3. If you add all that up, it comes out to be 0. And so that's how, even though each of these little pieces is charged, when you add up the charges on these three pieces, you get a charge of +1. When you add up the charge on these three pieces, you get a charge of 0. Okay, so we're going to talk more about these subatomic particles in the upcoming days. But for now, what I'm hoping you get, and I've given you two additional videos to take a look at, but what I want you to walk away with is that one of the types of subatomic particles is called quarks. Okay, so that's one type of subatomic particle. And protons and neutrons are both made up of quarks. So protons and neutrons make up, or the mass of, make up the brunt of the mass of all atoms. So almost everything that we see, feel, and touch is made up of protons. The mass comes from the protons and neutrons. And protons and neutrons are made of quarks. That's why quarks are the first thing we want to talk about, because almost all matter that we interact with on a day-to-day basis is made up of quarks. Okay, so protons and neutrons are built from quarks. Quarks have a fractional charge. We think of the charge of an electron as -1 and the charge of a proton as +1. So up quarks have a charge of +2/3, down quarks have a charge of -1/3. A proton is made up of two up quarks and one down quark. So +2/3, +2/3, and -1/3, giving an overall charge of +1. And oops, sorry about this. I meant to say a neutron is made up of two down quarks, okay, and one up quark. All right. And so for a neutron, I'm going to edit this as we go on. A neutron is comprised of an up quark, which is +2/3, and two down quarks, -1/3, -1/3, which gives us an overall charge of 0. Okay, so proton is made up of an up, up, and down, which adds up to +1, and a neutron is made up of an up, down, and a down. Oops, it should be down over here, sorry. Which gives it a overall charge of 0. Okay? And then the last thing I want you to walk away with is that anything that's made up of three quarks is called a baryon. So things that are made up of three quarks are called baryons. And since neutrons and protons are made up of three quarks, they're baryons because they're made up of three quarks. So neutrons and protons are considered to be baryons. because they are made up of 3 quarks. Alrighty, so take a look at the 2 attached videos and then answer the questions on the form. But we're focusing on quarks, and the most important thing is that neutrons and protons, we used to think of them as just these were the things that atoms were made up of. Well, it turns out that neutrons and protons themselves are made up of things, and what they are made up of is up and down quarks. All right, thank you.